How big is the universe? A cosmic journey through scale. Picture this. You're standing in your backyard, looking up at the night sky. That brightest star you see? It's not a star at all. It's Venus, our neighboring planet, reflecting sunlight from 25 million miles away. But here's the mind-bending part. That nearby celestial body is actually closer to you than most people are to their morning coffee shop, cosmically speaking. Welcome to the most humbling question in science. How big is the universe? The deceptive horizon. Let's start with what seems obvious. When we peer into the cosmos, we're looking at the observable universe. A sphere roughly 93 billion light-years across. Wait, didn't you just say the universe is only 13.8 billion years old? How can we see 93 billion light-years if light has only had 13.8 billion years to travel? Here's where it gets deliciously complex. While that ancient light was traveling toward us, space itself was expanding. The galaxy that emitted the light we're seeing today has been carried away by cosmic expansion to a current distance of about 46.5 billion light-years. We are essentially looking at cosmic fossils, ancient light from objects that are now impossibly far away. But here's the kicker. This observable universe might be just a tiny bubble in something unimaginably larger. Add the cosmic zoom out. Let's play a game of cosmic zoom out. If Earth were the size of a grain of sand, the observable universe would be, well, it would still be about 93 billion light-years across. The numbers become so vast that our normal scaling analogies break down completely. Consider this. There are more stars in the observable universe than grains of sand on all of Earth's beaches. But even that comparison fails to capture the true scale. The Milky Way alone contains roughly 100 billion stars, and we can observe about 2 trillion galaxies. Do the math, and you're looking at roughly 24 stars. That's 1 followed by 24 zeros. Now imagine each of those stars as a single atom. The observable universe would still be larger than Earth. Hi, Charles. The infinite possibility. But here's where your mind should start to melt. The observable universe is likely just an infinitesimally small fraction of the actual universe. Most cosmologists believe the universe is either infinite or so mind-bogglingly large that the difference is academic. If the universe is infinite, then everything that can happen has happened. Infinite times. There are infinite copies of you reading this right now, with slight variations. Some where you chose different coffee this morning, others where dinosaurs never went extinct, and still others where the laws of physics work differently. Even if the universe isn't infinite, if it's just very, very large, the implications are staggering. The mathematician Max Tegmark calculated that if the universe is at least 118 times larger than what we can observe, then there's another exact copy of you somewhere out there, living an identical life down to the quantum level. The multiverse elephant. Speaking of mind-bending possibilities, we haven't even touched on the multiverse. According to eternal inflation theory, our universe might be just one bubble in an infinite cosmic foam. Each bubble, each universe, could have different physical laws, different fundamental constants, different possibilities for complexity and life. Alan Guth, one of the pioneers of inflation theory, describes it like this. Imagine our observable universe as a single proton in a universe-sized object. Now imagine that object is just one of countless others in an infinite multiverse. We're not just small, we're incomprehensibly, hilariously small. The measurement problem. How do we even begin to measure something this vast? The answer reveals the beautiful ingenuity of human science. We use standard candles, objects with known brightness that allow us to calculate distance. Type Ia supernovas, for instance, always explode with roughly the same energy, so their apparent brightness tells us how far away they are. We also use the cosmic microwave background, the afterglow of the Big Bang, as a kind of baby picture of the universe. By studying tiny temperature variations in this ancient light, we can map the structure of the early universe and extrapolate its current size. But here's the fascinating part. Every measurement technique gives us a slightly different answer. The universe appears to be expanding faster than our best theories predict, a mystery we call the Hubble tension. Something fundamental about cosmic scale is still eluding us. The philosophical vertigo. Contemplating the universe's true size induces what I call philosophical vertigo. We exist for a cosmic eye blink on a tiny world orbiting an ordinary star in an unremarkable galaxy, in an observable universe that might be an infinitesimal speck in something infinite. Yet here's the paradox. We, the most fleeting and fragile of cosmic phenomena, are the only known entities capable of contemplating the cosmos itself. We are the universe's way of knowing itself, conscious matter pondering its own existence across scales that dwarf imagination. The expanding mystery. Every answer about the universe's size raises more questions. If it's expanding, what is it expanding into? If it's infinite, how did it become infinite? If there are other universes, what lies between them? The most honest answer to how big is the universe might be bigger than we can currently imagine, possibly infinite, and certainly large enough to make us reassess our place in the cosmic story. As we continue to probe deeper into space and time, one thing becomes clear. The universe is not just vast, it's so vast that vastness itself becomes a new kind of frontier. We're not just explorers of space. We're explorers of the very concept of scale itself. The next time you look up at the night sky, remember, you're not just looking at stars. You're peering into an abyss of possibility that might be infinite, in a universe that might be one of infinitely many, contemplating questions that push the very limits of human comprehension. And somehow, impossibly, that makes us not smaller, but more magnificent.